Exploring Saturn's moons reveals mysteries of life in the universe.
Over Saturn, so you can see the gravitational field. Its rings, they look impossibly thin, and they are impossibly thin. They're in fact only around 10 meters thick, so they would fit comfortably inside this auditorium. And they also, we found, are most likely young. What we think happened was that a moon came close to the planets, probably in collision with another moon, or perhaps a gravitational interaction with another moon, and then dissociated and broke up to form the rings. It's possible that they weren't there when the dinosaurs were on Earth. So if the dinosaurs had invented telescopes and looked up at Saturn, they may well not have seen that planet that we see today. Saturn has one of the largest moons in the solar system, Titan, which in this image you see above the ring plane. Titan is the only object in the solar system other than Earth that has liquid on its surface, but it's freezing cold, a long way from the sun, minus 180 degrees Celsius or so. So that liquid is not water. It's liquid methane, liquefied natural gas. So this moon has lakes and seas and rivers of methane. It has methane rain and methane snow, a methanological cycle in the same way that Earth has a hydrological cycle. We also think that it may have liquid water below the surface. So again, this is an interesting moon in the context of life. But there is another moon around Saturn that is equally, even perhaps more intriguing. It's a moon called Enceladus. What we see on Enceladus are fountains of ice rising up from the surface and disappearing off into space. Beautiful, but what we think is causing those fountains is even more beautiful. We're now, I would say, certain that there are lakes of liquid water below the surface of Enceladus. And on the floors of those lakes, we think there are geological systems called hydrothermal vents. Now, that is fascinating because we think that one of the prime candidates for the origin of life on Earth, 3.8 billion years ago, are hydrothermal vent systems, where you get energy in contact with rock, in contact with minerals, and that transition from geochemistry to biochemistry happened. So this moon is one of the prime candidates to look for life beyond Earth in the solar system. And when we look at images of Saturn, which are backlit by the sun, you see the sunlight illuminating the rings. There is a diffuse ring far away from Saturn known as the E-ring, which is created by the ice fountains of Enceladus. So it's a tiny moon, but with a potentially dramatic impact in terms of the creation of the rings, but also philosophically, intellectually, as a possible home for life. So Saturn, the bringer of old age in Holt's mind, is not a world enjoying a sedate old age. It's a dynamic world, a fast-changing system, constantly rejuvenating, raging against the dying of the light. And its moons, in particular, Tiny Enceladus, are perhaps engaged in the most spectacular rejuvenation of all. That natural transformation of rock and minerals and water and heat into living matter. The transition from geochemistry to biochemistry that brings meaning to the universe. We are now entering the mysterious dark frontier of the solar system. Uranus, the magician. These worlds would have been absolutely unfamiliar, no more than points of light, because they are so far away. When we look at Uranus through our most powerful telescopes on Earth, and here you see it through the VLT, the Very Large Telescope, it's powerful. You see that it's a planet you can see some surface features. It's a blue planet with white high-altitude clouds, and also 4 moons are visible in this VLT image. The image looks odd, though, because the moons are aligned vertically. The planet appears to be tipped up on its side, and that's because it is. That's one of the most mysterious things about Uranus. It orbits the sun with its poles leading the way. Now, why? It's almost certain that Uranus must have been hit by a large planet at some point in the very distant past, 4.5 billion years ago during the formation of the solar system, which tipped it over. Also from Earth-based telescopes, you see that Uranus has a ring system. It's nowhere near as spectacular as Saturn's rings, but there are rings nonetheless. Sunlight out there is only 1/400th of the intensity of sunlight here on Earth. Temperatures are very low. The cloud tops minus 224 degrees Celsius, but there are very powerful winds there. The winds at the equator move at 200 miles per hour, but in the opposite direction to its spin. Very strange. But as you move up through the tropics towards the poles, the winds reverse direction and blow in excess of 500 miles per hour. The moons are beautifully named, actually. They're named after Shakespearean spirits and spirits in English literature. So Umbriel, Ariel, Miranda. Now, the only spacecraft to make it this far out was Voyager 2. The photographs, because light is so dim and Voyager was travelling so fast, are quite blurry sometimes. There's a photograph of Umbriel, you don't see much detail. And Miranda, which is one of my sort of favourite moons because it really does look like some kind of drunken deity assembled it on their day off. It's a complete mess. Bits of rigid sort of bits of rock stuck on and big canyons. And the reason, of course, is it must have been split apart by a collision many billions of years ago and then reformed. So the Uranus system is a strange system. It's a long way away from the Earth. Voyager only spent 5.5 hours in the system as it travelled through, taking the only photographs we have from near the planet, and then left, leaving the strange, tilted magician behind in the twilight. In summer 1989, Voyager 2 arrived at Neptune, the true frozen outpost of the solar system, a planet that's known as an ice giant, dwarfs the Earth, but made, just like Jupiter and Saturn, Uranus, primarily out of gas. It's still very cold, minus 220 degrees or so at the cloud tops, but Neptune produces some heat internally. And so at some point, as you dive below the clouds and the pressures increase, there is, we expect, a zone where you could find perhaps liquid water. Neptune is a world of violent winds. We saw high altitude clouds as Voyager passed by, clouds of methane crystals, supersonic winds that blow at speeds of up to 1,200 miles per hour. It has moons, and the largest moon is a moon called Triton. And this is so far away from the sun, very little energy falls on its surface, but we saw activity. We saw geysers erupting into the air, geysers of nitrogen sprinkling dark material downwind onto its surface, processes that we don't yet fully understand, leaving streaks across the surface of the moon. But as Voyager left the Neptunian system, it took one of the most iconic images in the history of space exploration. I think actually it's my personal favourite. Present Neptune and a moon Triton, a world of ice, 230 degrees below zero, orbiting a blue planet of storms. These two worlds remained unseen for 4.5 billion years after their formation, until our tiny emissary from Earth passed by on its way to interstellar space. There are billions of planets beyond our solar system orbiting around the 200 billion stars in the Milky Way galaxy and in the billions of galaxies beyond. But we've discovered that solar systems and their planets are not necessarily, or even, perhaps, usually stable on the timescales necessary to allow complex life and civilizations to evolve. So we, the human race, might be extremely fortunate to exist, and therefore we may be indescribably rare and therefore precious.